Welcome back, algebra students. Today, we're going to be talking about writing exponential and power functions. So, we've already defined what we mean by an exponential function. And that's really just something of the form y equals a times b to the x, right? So we also want to talk today about power functions. So a power function is of the form y equals a times x to the b. And you might look at that initially and say, well, wait a second there, Mr. Kulik. Isn't that power function really just the same thing as a polynomial or a monomial, right? Like a time, 3 times x squared. Sure, a polynomial a monomial would be considered a power function. However, that b for a power function can be any real number. So you're not limited to exponents that are simply positive whole numbers like you are for a monomial. You can have decimals, you can have fractions, you can have positives, you can have negatives. The world is your oyster there as far as the b's go. So that's nice. For exponential functions, again, a can be anything, but b, that b has to be positive and not equal to 1. So what we're going to be looking at here in this section is taking some data and building a function to kind of describe that data that's either polynomial or power, and then maybe answering some questions about that. So let's look at an example here. Okay, so here's an example. So a store sells motor scooters. The table below shows the number y of scooters sold during the xth year the store has been open. So what this table says is in year 1, we sold 12 scooters. Year 2, we sold 16. Year 3, we sold 25, etc., etc., etc. First things we're asked is to draw a scatter plot for this data. So a scatter plot is just a plot of the xy coordinates. We're going to use our calculator to do this. And really, I'm going to use my calculator to do this entire problem. So to draw a scatter plot, the first thing I'm going to do is I have to enter this data into my calculator because this is what I want to graph. So to enter that data, I'm going to start by pressing the Stat button. Now from the Edit tab, I'm going to select the Edit command. And now I already have some data in my calculator from a previous class. If your data, or if your calculator is blank here, that's great. You don't have to do anything. If you do have data here, we won't need to clear it out of there so we can put in new data. To do that, I'm going to move my cursor up to the heading where it says L2. Then I'm going to press the Clear button, not the Delete button, and then the down arrow, and that'll clear the entire column. So I just did that twice. Now I'm going to enter all of my x's into L1. So that's just 1, 2, 3, 4, 5, 6, 7. And I'm going to enter my y's into L2. So 12, 16, 25, 36, 50, 67, and 96. And now as a helpful tip here, it's very easy to fat finger a button and type in the wrong number here. So I'm just going to take a quick glance through and make sure that I typed all these numbers in correctly, because the last thing I want to do is goof that up. Everything looks good. So what I'm going to do now is set up a scatter plot. To do that, I'm going to press the second button and the stat plot. I'm going to select plot 1. I'm going to turn on plot 1 by pressing enter where the on is. So this first option is the scatter plot. This is the one that we'll be using every time. I type my x's into L1 and my y's into L2. If you would happen to type those into a different location, the different list names here are on your keyboard. If you press second and the number 1, you get L1, second and the number 2, you get L2, etc., 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 all the way to L6. So depending on where you typed yours, probably L1 and L2, you probably don't have to do anything, but if you did, you'd have to change those so that it reflect the locations that you typed in your x's and y's. So I personally like to use the squares because they're easiest to see when it makes the scatter plot. So I'm going to leave that option there. And the last thing I'm going to do now is do zoom. Oops. I guess I have to exit out of here. And I'm going to press the zoom button. And I'm going to pick the zoom stat command. So the zoom stat is going to pick a window for me that's going to fit in the data that I had just plotted or entered into my calculator. And there we go. Oops. I had some stuff in there. I want to get rid of that. So there's my zoom or my scatter plot. So I have my scatter plot. The next thing it says is to find an exponential model for the data. The calculator is going to do that for me. So I'm going to just exit out of my graph. I'm going to go back to the stat menu. But this time I'm going to go to the calc tab. And I'm going to scroll down until I find the command that says exponential regression or expreg, which is right there. So I'm going to select that one. Again, my x's I typed into L1, my y's I typed into L2. Probably you did the same thing, but if you had to change something when you made your scatter plot, you'd have to change this again now. Frequency list, we're always going to leave blank. That's not going to be something we deal with here. But the store Reg Eq, we are going to deal with that. So what this is saying is it's going to build an equation for an exponential equation that fits this data. It wants to know where do we want to put it. So I'm going to put it into one of the y slots in my calculator. So if I go and I look at my y slots, I actually want to clear all that stuff out of there, because I'm going to place it into y1. Oops, so I guess I have to go back and get that again real quick. Should have checked that beforehand, I guess. Okay, so store Reg Eq. I'm going to store it into the y1 spot. So I'm going to press, to get the y1 to go here, I'm going to press the vars button. Vars is short for variables. The y is a variable. And the variable I want is a y variable, so I got to move over to the y-vars tab. And everything we're doing in this class, our calculator's in the function mode. So I'm going to go to the function option, and there's the y1 right there. And now I'll hit calculate. So this is my regression equation. So it tells me the form y equals a times b to the x. The a is this 8.457377971. The b is this 1.418848603. And you may or may not have gotten these r squared and r values. We're not going to worry about those for this course. Basically, the gist of it is the closer your r squared is to the number 1, the better your model describes that data. But we're not going to really do anything with those in this class, but that's what those are going on. And the R is basically kind of telling the same thing, just in a slightly different context. The R basically tells you how linear the data is, but that's beyond the scope of what we're trying to do in this class. These are statistical concepts. So what I'm going to do now is I can write down that information where I have my exponential, where it asks for my exponential model. And so let's do that real quick. So y equals 8.457. I'm going to just round those numbers to 3 decimal places. If I can write the number 8 times 1.419 to the x. Now, to predict the number of scooters sold in the 8th year, I'm just going to plug 8 in for x. So I could do that by typing this all out on my calculator, which is fine. Or I can do something else. So if I exit back out to the main screen just by pressing second in mode, and I go back into the vars menu, and I go back over to the y-vars, and look under the function option, I can retrieve the y1 again, and I can treat this kind of like a function notation and just say, let's do y1 of 8. What that's doing is it's plugging 8 into the equation for y1. So if I press that, I get about 139 scooters sold. Everybody okay there? Just FYI, if we went and looked at our graph now, you'll see this guy coming in. This is the exponential model that we had built. You notice it's a very good fit for our data as it lies very close to all of our data points. So it is a very good model. Let's look at another example. Okay, so in our second example, we have the typical wingspan, which we're going to represent with the variable x, measured in feet, and the typical weight, which we'll represent with the variable y, measured in pounds, of several kinds of birds are given. So the cuckoo wingspan is 1.9, and its weight is 0.23. These, again, are averages, or typicals. Crow, the wingspan is 2.92, and the weight is 1.04, etc., etc., etc. So we're going to create a scatter plot for this data, find a power model for the data, and then use that power model to predict the weight of a bird whose wingspan is 4.5. So it sounds very similar to the previous problem, and it'll work in a very similar way. So I'm going to do this all on my calculator. I'm going to exit out from my graph, and I'm going to go back and enter this data into my calculator to create my scatter plot. So I'm going to start by pressing the Stat button. From the Edit tab, I'm going to choose the Edit command, and I'm going to clear out the data that I had there. So I'm going to move my cursor up to the L1, press Clear, and then the down. Move my cursor up to the L2, press Clear, and then the down. And now I'm going to type in my new data. So 1.9292, 341, 535, and 840, and then 0.23, 1.04, 1.69, 676, and 1603. And again, before I leave, I'm just going to go and take a quick check to see if I typed everything in correctly. Don't mind that there's no 0 at the end. The calculator is going to remove the 0 at the end anyways. So that looks correct. Next thing I'm going to do is I'm just going to go up here real quick and clear out this thing that's in my Y1 spot. And then I'm going to go and do my zoom stat to look at my scatter plot. So here's my scatter plot for my birds. Okay. So that's that. Next, I want to find a power model for the data. So I'm going to do this in a very similar way that I found the exponential model. So I'm going to exit out of my scatter plot, go back to the Stat menu. This time I'm going to go over to the Calculate tab. And to make a power model, what I'm looking for is the command that's power regression. So if I scroll down, I see PWR reg. So I'm going to select that. I put my x's in L1, and put my y's in L2. So those are there. I'm going to store this regression equation into y1. So just like last time, I'm going to press vars, go over to the y vars, select the function, and then select y1, and then hit calculate. So I can use this information to write down my power model. So again, it tells you the form of the power model right up here. So I have y equals, and then my value for a, and again, I'm just going to round that to 3 decimal places, times x to my value for b, and again, I'm going to just round that to 3 decimal places. And now I can use that power model to predict the weight of a bird whose wingspan is 4.5. I'm going to do that just by plugging in 4.5 for x. So I can do that with my rounded, but then I get a double rounded answer. What's better is to use all of the decimal points from my calculator. And the easiest way to do that is to exit out of here, go to the vars button, select the y vars tab, and then from the function command, select the y1 and do y1 of 4.5. So I'm just telling the calculator to put 4.5 in for x into the equation that's stored in my y1. So that tells me I should get about 3.32 pounds. And just so we're sure, if you hit the graph button, here's again my scatter plot, and this is my power model, which you see is pretty good in the beginning and gets a little less good as it gets later on. But this is really as good as we can do for the data that we have. And that's really all there is to this section. So you're just going to be creating scatter plots, finding a power model for the data, and then using that power model or exponential model to make some estimations. Okay. And there'll be homework for this. It'll be worksheet 7. And it'll be posted to PowerSchool. Okay, bye-bye.